Now let's expand our approach to Bayesian approach. And here again, we will go one step at a time. So we will look at two approaches, okay, um, for the prior knowledge of birth defects. Okay. The first approach is we will ignore the first study. Remember, we had two studies, okay, earlier study and then a later study. So we ignore the earlier study, we only look at the second study. So we'll call that uninformative prior. So we're ignoring the information that's available from the previous study. So we call that uninformative prior. So ignore the first study. So we now look at prior probabilities for Zika related birth defects, and we will look at several possible scenarios. So we'll start with an assumed probability, prior probability of just 1% likelihood of birth defect, all the way through 100% birth defect in increments of 1%, 0.01. So we'll set that up in one column. Okay, so there's going to be 100 possible alternative values. They are all equally likely. And then we, so under these circumstances, okay, 1%, 2%, 3% probability, prior probability, what is the likelihood that we will get a study result like this? So which means if there is 1% probability of underlying birth defect, then what is the probability that in a sample of 76, 42 of them will have adverse condition? Okay, so that's our likelihood. What is the probability of the number of birth defects found in the second study given the prior probability of say 1%, 2%, 3%, 4%, and so on? So that would be our likelihood, and use this likelihood as our posterior probability. So that's it. So we are ignoring the previous study. And then of course these probabilities will have to be normalized because these probabilities will have to sum to 1. So we'll normalize that probability. So that's approach 1. Okay, so let's set that up, and then we will look at approach 2. So here uninformative prior here, then informative prior, our second approach we will set up here. Okay, so this is our prior probability. So we start with 0.01 and then in increment of 0.01. So this is previous one plus 0.01. Made a mistake. Plus 0.01. Okay, and then we will copy that formula until we get to one. All right, so okay, so these are the prior probabilities. Okay, so the likelihood then is we use the, so if this is the probability of birth defect, okay, what is the probability that out of 76 n trials, 42 will be birth defects? So that's just straight binomial distribution. Binom dot dist, right? Now B3, so that's the number of quote unquote success, which means birth defect, so comma, number of trials, so that's that again, since we're going to have to copy, and those two values must always come from B3 and C3, we need to make sure that they are absolute referenced. And then we have the probability of success, okay, and then finally we have whether we want probability mass function or cumulative probability. So we don't want cumulative probability, we want just the probability, so we say false. Okay, so now that's a very small probability, so that's why it is in scientific notation. So that is 3.22983 to the power of times 10 to the power of minus 63. That's a really small number. So we can't express that with you have to increase the size of the column so profoundly uh, that we have to increase the size of the column so much for us to be able to see. So that's not worth it. Now, that one is because, okay, so let's change this to, okay, so a number very close to 1, but not quite 1. Okay, so that's the reason why we were getting an error. So we'll do that. Okay, so we will use posterior as the same thing, right? Now in your textbook, you have prior knowledge of 1 and you multiply those two, which is the same thing. So we have the posterior. All right, now we're going to our final estimated P for the posterior probability is we have to normalize this. So what we need to do for normalization is, okay, I'm going to sum this. Let's put a border here. So let's do a sum of this. Okay, so it's a little greater than 1. So that needs to be adjusted. So we do that divided by that total. So that total must always come from D122. So that needs to be absolute referenced. All right, so now copy. So this is the normalized posterior probabilities. So they sum to 1. Okay, so these are the estimated probabilities for us given the underlying probability that we assumed is in A, and these are our calculated posterior probabilities. Now we can simulate, okay, simulate in an x value from here and the corresponding y value. So what we're going to do is we're going to fit a distribution between that and that. We did a similar one in the previous example where we used risk cumulative, and that's for discrete distributions. Now here we're going to use a continuous version of risk cumul, which is risk general. So, but before we do that, let's set up the second approach, which is the infinitive prior.